We're going to talk about the sine function, a basic equation that has the sine function. Now, typically when we graph things, we do it. We have what are our axes when we x and y. All right, you have our x-axis here and our y-axis here.
Use a different color. It's not coming up well.
Yeah, it's really light.
Yeah.
Use blue.
Or black.
Orange.
Well, I want to use black for something else.
Orange.
Red.
Orange.
We should go straight Halloween. Go orange and black.
That's right. Life of Pi.
Ha!
How's that?
Better. Let me scoot in a little bit. Okay, that'll work.
Okay. All right. So typically when we graph things, we have our x-axis and our y-axis. And then we graph things. We have certain, 1, 2, 3, 4, positive, we have 0, and then x of 1, 2, 3, 4, and then we go to negative 1, negative 2, negative 3, negative 4 on the x-axis, and on the y-axis, so this is also 0, and we can count 1, 2, 3, 4, etc., or negative 1, negative 2, negative 3, negative 4, one like that. This is what we're talking about, x and y. When we're talking about something with angles, we're going to take the same idea, except instead of x and y, we're going to do theta and y. We're going to call it the same thing. Draw this. We're still going to have a horizontal and vertical axis, but what we're going to do is we're going to make this one really long. And we're also, because it's easier to learn, let's learn this in degrees for now. You can do it radians later. But we're talking about an angle in degrees. So this is still 0, 0. Let's do, let's say that this is, let's say that this is 180 degrees. And so then half of that would be 90. Half of that would be 45 degrees. That means 30 and 60 are about here and here. All right, these are the angles that we deal with most often. 0, 30, 45, 60, 90, etc. And you'll see why in just a minute here. Let's make this be 1, 0, and negative 1. All right. Now, grab your calculators. What is the sine of 0 degrees? 0. 0. Okay.
You trickster.
So in this equation right here, or this function, if I plug in a 0 for theta, the sine of 0 degrees is 0. So 0 on my theta is also 0 on my y. All right? Now, what's the sine of 90 degrees? 1.
Positive.
1. So for this same equation or function, plugging in 90 degrees gives us a y value of 1. Now, what is 40? So what's the sine of 45?
2 red 2.
Rad 2 over 2.
Red 2 over 2.
Okay, hang on a second. Let's see. We'll make this 0.5. What's rad 2 over 2 as a decimal?
0.
I'm not sure.
7.707.
Okay.
You got it.
0.707, or however you want to round that. So at 45, 0.7. Let's see. So this is 3/4. So this will be 0.75. This will be 0.25. All right. So at 45 degrees, the sine is 0.72. So we're just a hair lower than here. So we're about right there. All right. What's the sine of 60 degrees? It's 0.866. So at 60 degrees, we're probably about up here. Where are we at sine of 30 degrees? Quick, what's the sine of 30 degrees?
1/2.
1/2.
1/2.
That's 0.5. So at 30 degrees, we're at 1/2.
That's right. Team building.
Now, what does it start to look like here? Now, it almost looks like a straight line, a little bit of a curve to it. Let's keep going over here. What's the sine of 180 degrees?
It's the squiggly.
0.
Sine of 180 is 0.
It's a semicircle.
What's the sine? What's halfway between 90 and 180?
135.
135. What's the sine of 135?
You're amazing. Caliber.
0.707.
Yep, that's the 0.707. So that's going to be, that's this one right here. So we're going from here, here, here. What this looks like is a curve like this. All right, let's see what happens when we go in the negative direction. Try to get a similar scale here.
Down first.
Negative size down.
Goes down.
All right, let's, what's the sine of 90 degrees?
Roller
Oops,
coaster.
that's negative, my bad.
No,
All right,
it's
what's the
more.
sine of negative 90 degrees?
It's a roller coaster.
-1.
Negative 1. So about here. What's the sine of negative 180?
180.
Also 0. What do you think the graph's going to look like?
It's gonna be like.
It's like a nice straight curve here.
So it's like a dolphin.
Polar.
It's like the path of a dolphin going up and down out of the water.
So this is the graph of the sine function. All right. So this is what the graph of sine looks like. And as you can probably figure out, if you haven't already, if I keep going, it's just going to do a nice gentle undulating motion here. Oscillating.
Undulating.
Yeah, throw some good, nice vocab words in there.
Oh no.
Oscillating.
Right. Now let's do the same thing with cosine.
Cosine.
All right, we've got our theta axis and our y-axis. Let's do -1 here, +1 here, and 180 degrees. And see, half of that is 90 degrees, half of that is 45 degrees, and half of this is, let's call, say this is about -90. I'm a little bit off, I think, but -45 and -135. Okay. All right. Now, grab a calculator. What's the cosine of 0?
Definitely 0. Or 1.
No.
Maybe 2.
It's 1.
What? Cosine of 0? 1. All right.
That's what I
What's the
said.
cosine of 90
Wow.
degrees?
Oh,
0?
It's 0.
What's the cosine of 180?
Negative 1.
definitely.
-1. What's the cosine of 45?
0.707.
There's my 0.707.
Okay, no cheating.
Cosine of 135?
Negative 0.707. Negative
-0.707.
0.707.
Good job.
Cosine of -90?
Zero.
That
0.
is
Syntax.
Cosine of negative?
0.
You could use the subtraction button instead of the negative. All right, what's cosine of -180?
-1.
-1. Cosine of -45?
0.707.
Yep.
0.707. Cosine of -135? -0.707.
Yeah.
So what does this look like, do you think?
Looks like a hill.
What?
It's a thumb.
What?
Oh, whoops.
You missed one,
Oopsie.
silly. Connect them. Just for fun.
Then it'll look like a roller coaster with a steep hill.
Do they have the same shape?
Yes.
Yes, they do. It's just shifted over 90 degrees.
Let's do tangent next.
We will in a later lesson. All right, so what I want you to write on your formula sheet,
No.
what you should write on your formula sheet, notice my keywords formula sheet here.
Formula sheet here.
Sine of the sine function. The sine function starts at 0, 0, and it starts by going up.
Here comes the Alamo.
Alright. I recommend that you do this much detail, not anymore.
Okay.
So where I started here, I did the 0 to 180 degrees, and I
Which
did
is
and I did negative 180 degrees. What I went on here, I'm doing from 0 to 360.
Gotcha.
The nice thing about getting this idea in your head. Give you a couple more seconds to write that down.
Yeah.
The nice thing about having this written down is if you know that sine has this basic shape, it has the curvy shape, and you know that it starts at 0, 0 and goes up, just knowing that, what's the sine of 0 degrees?
Definitely 0.
What's the sine of 90 degrees? Sine of 180. Sine of 270. Sine of 360.
0.
See, that way it makes the quadrantal angles, right? 0, 90, 180, and 270, and 360. It makes those ones easy to find if you just know this much. Same thing with cosine. Cosine, if I start at 0 degrees going to the right, starts at positive 1. It goes like this. 360, 90, no, 180. This is 90. This one's 270. And we have negative 1, 0, and 1. Cosine has the same shape, except it starts at the top and then goes down.
Cosine.
So, quickly, what is the cosine of 0?
1.
Cosine of 90.
0.
Cosine of 180.
Negative 1.
Cosine of 270.
0.
Cosine of 360.
1.
1. And that is
Baby in a nutshell.
that is the main idea. We'll give you. There's going to be tomorrow. I will show you how to change one thing about this, and then we'll be done with the lesson. Our introduction to sinusoids. Sinusoid is a generic term for a graph that looks like the graph of the sine function. So sinusoid, that means looks like the graph of the sine function, which looks like this. Right, it's a squiggly like that. Both sine and cosine have this shape, and so even though so we call them both sinusoids, meaning that they have that general appearance. So we did, and I showed you that for the sine function, it starts at 0, goes up, and goes like this. So from 0 degrees, 180 degrees, 360 degrees, and it goes from negative 1 to 0 to 1. And this is basically what it looks like. And then cosine, the cosine function starts at the top and goes through one complete cycle like that. 60 degrees, 180 degrees, 0 degrees. This is 1, 0, and negative 1. Right. Now, the one additional piece of information from this is that if we multiply this by something, what that does is that stretches the graph this way. From the center line. This line, this one right here is the center line. Center line. All right. All right, we have the center line there. How far is it from the center line up to the highest point in this graph? What?
1.
1. How far is it from the center line to the lowest point?
1.
We'll draw this over here. So the center line to the lowest point is also 1. It better be the same number because otherwise the center line wouldn't be in the center. Right? So the graph, it goes a certain distance above the center line and the same distance below the center line. Same thing with cosine. It's just that the peak and the valley are in different places. So that distance is 1. We call that distance from the center line to the peak or the center line to the valley. We call that the amplitude. And in the equation here, we're going to use the letter A to stand for that. The other way you can think of it, so the amplitude is either you can think of it as the distance from the center line to the top, or the distance from the center line to the bottom, or if you just say the total distance, it's half the total distance between top and the bottom. You can think of it any of those ways. Yes. So in this equation right here, it's a sine. It's the graph of the sine function because it starts in the middle, going up, and then does its loopy stuff there. And so we have it's a sine function. Let's say that instead of going to the top and bottom 1, let's say that this was up at 2 and this was negative 2. What's this distance now? 2. So we would do it here. So the A is the number that you multiply in front of the sine or the cosine. If I do this one here, the A times the cosine, or A times the sine. This graph here would be y equals 1 cosine theta. If I change this,
I don't get how you tell whether it's sine or cosine.
at the y-axis, where your angle is 0, does it start in the middle going up, or does it start at the top going down? All right, so with this cosine graph here, let's say that how far do you want to make this distance? 8? All right, let's say if this distance was 8. That would make this 8 and this negative 8. All right, distance of 8. So what would the equation be? It's a cosine graph because it starts at a peak.
8 cosine theta.
But it'd be an 8 because the distance from the center line to the top is 8. Now, one other thing. Let's say let's take this sine graph and flip it. What did I just do? How do you flip something across the x-axis?
Inverse.
Negative.
Put a negative where?
Right before the number.
Right before here. So let's say my graph started in the middle. If my graph starts in the middle, it's a sine function. If it starts at the top or bottom, it's a cosine function. This one starts in the middle, so it's a sine function, but it goes down, therefore it will be a negative sine function. And let's say that this is down at -4 and this is up at +4. What's my amplitude? What's this distance? 4. So
Negative.
if this distance is 4 and this distance is 4, then the equation of this would be y equals -4 sine theta. The fact that it starts in the middle, of the graph, that means you're talking about a sine function. If it starts in the middle going up, it's a positive sign. If it starts in the middle going down, then you've taken this and flipped it, so you need a negative in front of the sign. And then the amplitude is the number that goes there.
Okay.
So by the same token, the cosine graph normally starts at the top and goes down all the way back up again. So if you have a graph that starts at the bottom and does this, then you know that it starts at the top and bottom, so you know it's cosine. Cosine normally starts at the top. This one starts at the bottom, so you know it's a negative cosine. And let's say that the amplitude in this one is 3. That would mean that this goes up to positive 3 and this goes down to negative 3. And so the amplitude is always a positive number. So it's just, you know, what's the distance between the center line and the top. And so that's the other piece of information you need to do number 7 and 8 is that you can change the amplitude, you know, how far above and below the center line the graph goes by changing the number for the amplitude, the number that you multiplied by, and you can flip the graph vertically by multiplying by a negative. And that's the rest of what you need to know for that.